So I'll start running through. I have a little bit more of an intro here in a minute or so. So the modern data stack is kind of the word that like the people who promote it like to call it. Modern sort of implies that everything else is not modern or is old-fashioned or whatever, which I think is a little bit hubristic. I'm not like an evangelist of this particular stack, but I had some time in between clients, and so I decided to do some research on some stuff that I found interesting. So I'm going to share the results of that research. There's some folks on the call who've used different pieces of these more than I have, and so I'm hoping we can have a good discussion today. I love it when people ask questions, so feel free to interrupt me as much as you want to. If nobody interrupts me, I might pick on people and see if you have any thoughts. So all of this is cloud stuff. Every single piece of this stack is in the cloud. Some pieces are more well-known than others. Snowflake is very popular for, I think, good reason. FiveTran is somewhat well-known. DBT is relatively well-known, probably a little bit more than FiveTran. And Sigma computing, probably nobody's ever heard of that before today. If you have, I'd be impressed. So we've got an agenda. Let's see if I can start putting things up on the screen. So first a bio of me, a little description of the things about the stack and why you should care about it. What are the pieces and the different roles that they play in the process. And then if there's time at the end, we'll do a demo where we'll run some data through the stack just so you can see the basics of what it does. Any upfront topics that you want to make sure that we talk about that I don't have on my agenda? Or questions that you want to make sure we get to at some point that I should make sure to cover? Okay, I'll keep moving. And then just by way of background, I am not an expert in any of these technologies. I've just spent a couple of months playing with them. And so that's the extent of my knowledge. I haven't used any of these things in production. So me, how did I get into all this stuff? I have done a lot of different things in my life. That you can see my wife and my daughter there inside a greenhouse and an aquaponics setup that I built. Aquaponics is like a way of growing plants and fish together. I worked at the fish farm for a while. So I installed flooring, I've done electrical engineering, I've evaluated energy efficiency programs, I built aquaponics systems for a while, and then I moved into data analytics. And since last year, I've been consulting on a solo basis at running my own company called Information Assets. And so it's been an interesting ride. I've been doing lots of stuff. I love to learn. So what is the modern data stack? Well, there are a number of databases that have emerged in the past, let's say 10 years, that are different than the databases that were available prior to them. The first one was Redshift, and then along came Google. So Redshift is an Amazon Web Services product, and then came BigQuery, and then there's another database called Vertica. And then SnowFlake came along, and there's certain features of SnowFlake that are really nice. But essentially, these are all cloud-optimized, auto-indexing, auto-scaling databases that operate in a more flexible and generally faster manner than the databases that have existed prior to them. They're sort of automatically published with column store indexes, and they create them themselves. And so there's certain things that these databases can do and certain things that they can handle that previous databases had struggled with. And so they enable certain things that are kind of interesting. And I don't know that the full implications of all the things that they can enable have really been figured out yet, but there are a few things that are kind of interesting that I think have led to this, what people are calling the modern data stack. It's the ability of these cloud-enabled, cloud-optimized databases. The modern data stack includes certain amounts of automation. For the entirety of data analytics work, the vast majority, since like the 1970s, the vast majority of the work has been cleaning and modeling the data, right? Getting it into a form where you can actually do meaningful analytics. And there's always been people who have been over-promising how much of that process you can automate. I've been in many presentations where people have said, we take out 90% of the grunt work, we take out 85% of the hard work that database developers have to do, and they've all just been over promises for all these years. There's not a huge amount of this process that is automatable, but there are aspects of the process that can be automated using some of these new pieces that were not previously very automatable. So one process that you can automate is replication. So if you have a source data source, if you have a data source that's relatively consistent across organizations, where it's generally organized the same way, like QuickBooks or certain CRM softwares are often not customized that much, you can replicate all the data out of that data source into your destination system, right? So that could be SQL Server or SnowFlake or whatever else, but you can get it into a centralized database without a huge amount of work. That part can be automated for the most part, unless you have a highly customized system or a weird one or a really old one. Testing can be automated. Application developers have been automating their testing forever, for decades now, and database developers have done this some, but not nearly as much as application development and web development people have. And so the tools that were enabled for testing, automated testing, have been there for a long time, and they've finally gotten to the point where they're starting to get more adoption. And some of these newer tools just have them as like the native, you always do testing in an automated way. Deployments can be automated. When you're using, your ETL process is stored in a Git repository, and you're doing branching and merging, and you're doing pull requests from one environment to the next, you can automate deployments. I've been doing that for a long time. Skyline, where I worked for a while, had a process where they automated their deployments. And it's really nice. That's an aspect that you can automate. So there's certain aspects of the ETL or the data analytics pipeline process that you can automate in a way that you couldn't really do, let's say, 10 years ago or before these cloud optimized systems came into being. Because of these cloud optimized databases, there are certain aspects of database design that you can potentially do faster, right? So, we're in a world now where compute and storage is relatively cheap, but database developer time is very expensive. So if you can trade database developer time for compute and storage dollars, you're generally going to come out ahead. So, this is like, we'll talk a little bit more about this, but you can use your source system keys as the keys tying database tables together, right? So this is a direct violation of the Kimball methodology that many of us have been, sort of following as gospel for a long time now. But if you take the source system keys that feed together to create the unique record at the granularity level of a given destination data warehouse table, you can hash together your source system keys, and then you can do the same thing in your fact table, and that hashed together key can be your join key, right? Now, I haven't done this at massive scale, and I don't know if anybody else on this call has, but there are people who found that it does actually work. That with some of these new cloud optimized databases, you don't need necessarily to have the integer keys that Kimball was always designed around for slower databases. So this is an interesting question here, and we're going to have a forum in June where some people who have different perspectives on the modern data stack will come in and share whether they have experiences as to whether these kind of hashed keys work at scale. Some of these cloud optimized databases, at least in moderate size, if we're not talking about like a true big data scenario, can sometimes get by without needing a semantic layer. So like in the Microsoft stack, which many of us are used to, you use SQL Server to do your data warehousing, and then you publish that to an analysis services cube or to Power BI dataset and Power BI Premium, and that serves as your semantic layer, right? Or Tableau server would serve as your semantic layer, and that is the place where data is optimized so that you can run very fast visualizations on top of it. Now, some of these cloud optimized databases, there might be limits to what they can do at scale, but you can actually use them as your semantic layer, right? So you have your data warehouse that is also your semantic layer, and you push your data analytics queries back as SQL, and they can process fast enough in a direct query mode that you don't need an additional layer. So, I've seen that work. I haven't seen it work at massive scale, but I also haven't seen it fail at massive scale. So I just haven't seen it. Let's see. I don't even remember what I meant by this last note. So I'm not going to try to figure it out. Any questions about what is the modern data stack? Or any clarifications that you want to add to what I've said?
Hey, Jeremiah, one question. This is Brent. If you and I had talked about like Burst, another cloud BI tool, how do you see that fitting into kind of this modern data stack?
I don't have a huge amount of experience with Burst, except for having it evaluated briefly for one client. Burst is a product that's put out by Infor, and my understanding is that they're marketing it with some automation for Infor ERPs. So if you bring data out of an Infor ERP, there's a certain amount of efficiency that they can bring to that process. I don't have much more information about whether Burst pushes back the SQL onto the cloud database like like some other people are doing in this modern data stack world. So I'm sorry, I can't say a lot more about that. If anybody else knows much about Burst, I'd be interested to hear.
What are some of these modern data stacks? I mean, brand name wise, or
sure. So hold that thought for about 5 minutes, and we'll discuss that more.
Okay, good.
Yep. Other questions or comments? You can see the stack of pancakes here. We can get our own maple syrup from our yard. We have some maple trees that we tap and make our own pancakes. And I always try to, at one point in every presentation, put something where it says the goal is action. This is always sort of my frame for any BI project, because it's really easy to get caught up in the tech. The goal of all BI projects is to get people to do something differently. And so for the modern data stack or any other tool to be better than anything else, it needs to be better at getting people to do stuff differently, providing them information or whatever they need to be able to make better decisions. Okay, so this is sort of a place where you'll see this diagram, and then you'll see another diagram below that compares the two stacks, and you'll see for the most part that they don't look that different. The people who promote the modern data stack like to make it sound like it's completely revolutionary and you can just throw the whole old world away and everything is completely different. My experience is that that's a little bit of an oversell. And you'll note the note up here that in some cases I've used branded icons here, and the normal ETL solution isn't specifically required to use these tools. You can use other tools. And so you start with your data sources. Everybody's seen diagrams like this, hopefully. You replicate those into a staging area, often called an operational data store. And some of the modern data stack folks act like there has never been an operational data store, that replicating the data is completely a revolutionary concept, which it's not. People have been making ODSs for a long time. So you replicate your data into a staging area. You transform it and you model it, in the Kimball world into a star schema, which most people in the business world use Kimball models. So you clean your data, you structure it using extract queries, and then you generate your facts and dimensions in your physical dimensional model. Having this model, then you usually extract or pull the data into a semantic layer, which is optimized for very fast response times when you're building BI solutions. So this is a typical ETL solution. Any comments or questions about what a typical ETL solution, a typical data warehousing stack looks like? comment was made before about Burst. Burst sits over here. I don't know if Burst has its own integral semantic layer or not. Do you happen to know, Brent, if Burst includes a semantic layer, like an underlying analytics database?
It appears it's got, I mean, I've just read through some of the documentation because I've got a client that's evaluating it kind of like you. So I haven't engaged much. It appears it's got like sort of some sort of roll app type thing involved in it, but no, I don't know.
I do have a lot of experience with the Microsoft semantic layer, the analysis services. And when I first used analysis services after having a lot of experience with SQL, I was shocked at how fast it was at processing queries. It was dramatically faster, about 100 times or more faster than I was used to seeing query response times in SQL. So having a query and an online analytical processing in an OLAP database makes a huge difference in my experience compared to a transaction processing database. Okay, and then this is what the folks who promote it call a modern ELT solution. All right, so they call it ELT because you extract and load the data first, and then you transform it. So the stack looks relatively similar. You can see the ERP, which is often on premises up here, is harder to pull out. These replication tools are not all designed to be able to, like, you know, SSIS has a million drivers that you can use to pull stuff from. These replication tools are not always, you know, super well suited to pull data from an on-premises database, especially like the old databases like, you know, IBM and stuff. And so this can be harder. And so what some people do when they have an old on-premises database is they'll make a hybrid model. So they'll leave the regularly accessed data in an on-premises instance, and then they'll have a cloud instance of their ERP that replicates and archives old data up there. So when you want to pull data in using a replication tool, you contact the cloud version of it, which can work pretty well. But you know, some of these old ERPs, it's not quite as easy to use in the modern data stack. So then you have a replication tool, which is designed to be really, really user-friendly. So you tell it where the data, and if we get to a demo, we can look at this with FiveTran. You tell it where the data is, and you log in, and then the replication tool basically does everything after that. It just pulls on all the tables that you need, all the ones that you click boxes for. It does incremental loads and performs change data capture based on the keys that it identifies in that source. And you know, from that point forwards, unless you know, there's some kind of timeout, like your login to the ERP only lasts for a month at a time or something, you know, you're good. Like it's just going to keep replicating. And then you still have an ODS layer. We have the SnowFlake logo here, so you can land data here in your database. And then you do your transformation and modeling. dbt is the tool we're going to talk about today. One of the interesting things, which we'll talk about more, is that folks who promote tools like this in the modern data stack with databases like SnowFlake suggest that you can often get away without having to model the data, clean it, and then set it back down. You can often just create views, right? So you have your ODS, and you create a view on top of the ODS that is essentially your dimension or your fact table, and the database is fast enough that it can handle live processing your view at query time. And so I haven't seen that at massive scale, but it can work at medium scale. And so that's kind of interesting. So whereas previously you would definitely have set down your data as a dimensional model in tables, and then you would further have pulled it into a semantic layer. In many cases, people can get by with only having one copy of the data, and you just use views, essentially, that are defined by dbt or a tool like that as your analytics processing layer, which then you run queries against from your BI tool. So essentially, you have only set the data down once, and it's just views on top of that data that is the only modeling you're doing. Questions about this or comments?
Yeah, I think what you're talking about there with the views, I've known to be called virtualized data marts or virtualized data warehouses, and you can there's even tools for that. If you look up, I think Denodo is a big one that promotes their virtualization capabilities. I don't know how well they perform, or Denodo performs, or outside of the demo that they might give at a conference, but the idea has always been one of kind of like the pot at the end of the rainbow that I always wanted to get to, was that ability to have the virtual data warehouse, so that so yeah, we don't have to have the time to move the data in that last transform step.
Yeah, and like if that really can happen, and it can happen at scale, then all of a sudden your nightly data warehouse load is just a copy, and it's an incremental copy. You don't have these like 12, 14-hour loads. It's just not even a thing that would exist anymore if that promise is really true, right?
Yeah. Yep.
Does anybody have experience with Denodo or any of the other data virtualization tools that Jeff is talking about? Either in production or just having evaluated or even heard things about them?
I don't have experience with it, but I'm gonna tie it back to your previous comment about developer time being expensive, and that's really what it comes down to for us. We've been using DBT, and I mean, making views is extremely easy and doesn't really take a whole lot of developer time. But as you like make that a table or make that an incremental load, that becomes more and more complex and more time to troubleshoot and deal with issues that may come up. So something to consider there. I mean, it's sometimes a lot easier to just make your warehouse bigger, or in SnowFlake, which is your compute, make that bigger and pay for that instead of spending another 10 hours for a developer to troubleshoot an issue.
Right. So it's like, we could optimize this query, or we could just buy more compute.
Yep, exactly.
And buying more compute is often cheaper.
Yeah, and exactly. And if you're doing those incremental loads, I mean, that can become a problem, because then you have to troubleshoot, what happened, why is this data missing, what happened between these different loads, different runs. You just put a view over the top of it, it's always the same thing every time.
We're using a lot of terminology here that maybe not everybody is super familiar with. If there's anything that you're not sure what we mean, please ask. Any other questions or comments on this slide? Okay. So going in order from the extract load, or like replication layer, the tool that I evaluated is FiveTran. It's an automated replication tool. It's really easy. There's 170 cloud data sources, and there's a number of databases that it can connect to in an on-premises manner. And then you can connect to basically any API, but building out those APIs is actually fairly complicated. You basically have to build an Azure function or an AWS function to connect to the API and then pass the data along to FiveTran. So those are not easy buttons. But for the 170 data sources that it is already configured to connect to, you basically enter your login information, it pulls the data, and it tells you I'm done. And so it's really, really easy from a replication perspective. I was surprised how easy it was. And the instructions are extremely good. It basically shows you a view of your product that you're pulling data from. And it's like, click this, look this up, and paste this into FiveTran. It's like really good instructions. So it's an automatic replication tool, and it really is automated. And if your source data, which their 170 data sources all do, has some kind of unique key, it will do change data capture for you and set the necessary flags like you're used to when you do change data capture using Microsoft tools. It just does that for you with all of those data sources, which is really nice. Advantages include idempotence, which is a term I had to look up when I first heard them use it. It's basically when you pull a bunch of data based on a given set of timestamps, and then you erase all that data and you do it again, you will always get the same data, right? So each pull is truly replicatable. That relates, I think, most to like if you pull data and you have to assign a new key to it, right? Like a integer primary key, and like an integrating starting with 1 going up as integers, and you pull 10,000 records and then you delete those and you pull 10,000 more records, that key will start at 10,001. And so now your new row is different than it was before because you've introduced something new. So this concept that when you pull rows and then you pull them again, you get the exact same thing makes for a lot of flexibility, because then if you can trust your source system keys, then the tie between the fact tables and the dimension tables for people that know much about data modeling are, anytime you do a partial load or you need to truncate and reload one table, you don't have to truncate and reload everything and do all the lookups all over again. It's just ready for you. That one table truncate and reload is all you have to do in that case. So idempotent is the concept that makes that possible. I mentioned this, it's easy for the sources that are defined by FiveTran. And actually, you know what? I want to go back real quick here to this slide and talk about Peter's question. So we have a replication tool, we have a database, we have a transformation tool, right? It's not an ETL tool, it only does the T, it only does transformations. And then we have a BI tool. In the cloud or modern data stack world, and let's do one piece at a time, what are some other tools that do this replication function? So some that I know are called HBR. There's another product called Stitch, and then there's another product called by Click. I think it's called Click Compose. It used to be called Attunity. Are there other products that provide this kind of replication, automated replication that you know of?
Does Talend fit into that category?
Jason, what do you think?
I would put Talent in there. Matillion, I think, also could fit in there. Click's tool is actually called Click Replicate. Click Compose is more of a warehouse automation tool. Still part of that stack, but Replicate is the actual replication tool.
Any others that do this replication? Replication tools often suggest that they're good at other things too, but often the core function is replication. Was somebody gonna say something?
SQDR, that's another one. StarQuest Data Replicator.
So cloud optimized databases. So SnowFlake is the example shown here. The first one I mentioned that became popular was Amazon Redshift. Google BigQuery is one. I've used a little bit with a product called Vertica, which I think is owned by HP. That's optimized for data science. I think it might actually be the fastest, but its documentation is not that great, and there's other problems with it. Other cloud optimized databases that are columnar databases and auto scaling that could potentially fill this niche. I wasn't expecting responses to that one. There's not really that many databases out there that take a long time to build, and so there's only really a few examples. Transformation tools. So DBT is the one I keep hearing about. Some people use Alteryx to fill this role, to do the transformation step. Any others that people are aware of? In particular, those that can allow you to check in your transformation code into Git, which I think is one of the major advantages.
ADF, you can do that.
That's right. Yeah, Azure Data Factory. Jeff, have you ever looked at the code that gets checked in? Like, what does it look like? Is it understandable? Can you write it without using the GUI?
No, I haven't looked at it in a little while. I don't think you'd want to write it without using the GUI, but I think it is. It's a markup language backend, so it might be XML, might be JSON. I don't remember.
Yeah, I believe it's all JSON. The whole, similar to SSIS, everything was basically in XML format. ADF has everything in JSON.
Have you ever approved a pull request from ADF, Brigitte or Jeff?
No, I've not.
Yes, I've created a pull request and had somebody else approve it.
And did you feel like they could do a meaningful review of it, looking just at the code?
I mean, yeah, and yes and no, right? I mean, since it's graphical, yeah, it's yes and no. To an extent, you can, right? Just it's the same issue with any other graphical tool that you're checking in XML or a markup language for. You've got to have a better understanding as to what to look for there than just being able to see it represented. You know, any changes represented graphically.
Understood.
So it's harder.
Yep.
Any other tools fit this category? Transformation tools? And ADF is Azure Data Factory for anybody who was wondering what we were talking about.
I just had a question on the previous one. Does Azure count as one of these cloud scaling databases? Or not really?
I don't think so. So I've used Azure SQL DB quite a lot, and it's definitely not a auto-scaling columnar database. Azure SQL Data Warehouse, which is now called Synapse, it can be extremely massively parallel processing, but my understanding is you have to configure the scale out yourself. It's not auto-scaling. It's very well defined by the developer. Last time I looked at it was a year and a half ago, so it could be different now. Does anybody else have anything to add to that?
Yeah, they have. So they did evolve that product to the Synapse Analytics, and they added a serverless component to it. I wouldn't say that it is exactly comparable to SnowFlake, though, because especially the serverless component of it is really leveraging Spark pools underneath it all to do the query processing. So you still do need, you really need a good data architect, data warehouse architect to actually build something that's going to work properly, as opposed to the claims from the Snowflake side.
That's interesting, Brigitte. That's the first time that I had heard that Synapse is now relying on Spark for its massively parallel processing scale out.
Well, no. So Synapse, this is it's an annoying Microsoft feature, right? They suck at naming and renaming and all this stuff. But you're referring to Azure Synapse, used to be called Azure SQL Data Warehouse, which is the MPP platform. They now rebranded all that stuff to Synapse Analytics Workspace, which is kind of a combination of multiple different technologies. And one of the new things that got added into it is a serverless SQL pool. So the MPP, the traditional MPP you're thinking about is the dedicated SQL pool. That's pretty much the same as it was last year. The net new feature is the serverless piece that allows you to throw CSVs and like Parquet data and whatever into data lake, and then utilize the SQL layer to do your analysis, or do it in Python if you're more comfortable with that language set.
Thank you. So yeah, I think Azure SQL Data Warehouse doesn't really fit the characteristics that I'm thinking of when I'm describing an auto-scaling database of this kind. So then BI tools. So many of us are very familiar with Power BI. Power BI, in my experience, and what I've seen from other people's sharing online, doesn't work extremely well with Snowflake or any other relational database as their backend. They really do want the data in that semantic layer, the analysis services tabular model, or the Power BI premium, or just the Power BI service, data set. Tableau, I'm told, works relatively well pushing SQL back into a Snowflake database or another columnar database to use as the semantic layer. Looker is probably the most popular tool, which was recently bought by Google for doing this. Sigma is kind of a new player on the scene. Other BI tools that sort of play in this modern data stack world.
I'm not very familiar with it, but I've heard mode is getting a lot of attention lately, especially from DBT users.
Oh, interesting. And that's a BI tool?
It is, yeah. They have a lot of DBT integrations.
Okay, sorry to backtrack a little bit. I had forgotten that I wanted to talk about that in that context. Did you have any other questions about that, Peter? You had originally asked that question about other alternatives. Did we answer your question?
Yes, you did. Thank you. Oh.
Yep. Was there anything else you wanted to say?
Am I muted now, or can you hear me?
I can hear you.
Okay. No, it's all answered. Thank you much.
You're welcome. Okay, so advantages, change data capture we mentioned, that's pretty neat. It can be your orchestration tool. So FiveTran both can run its own replication processes and you can schedule them. You can schedule them as frequently as 5 minutes. It can also call other things, in particular DBT. So it can do its replication and then it can call DBT saying, hey, DBT, do your transformation step. So it can be your orchestration tool. For people using like what they call the modern data stack, probably the most popular orchestration tool, if you want to use more than just FiveTran and DBT, is a product called Airflow. It's an Apache product, and you actually write your orchestration code in Python. So, you know, one advantage to FiveTran is it can be an orchestration tool. At small scale, right? So this presentation, I think, is focused on smaller to medium-sized companies. For really small companies, like less than $50 million in revenue, Power BI by itself with no database at all works pretty well as a BI tool. You just suck the data into Power BI, keep it in a data set, you're all set. And then once you get to a large enough scale where it makes sense to build out a data warehouse, then there's a lot of resources for people at that scale. But there's like this middle layer where I've just not seen a great set of tools. FiveTran at that scale works really, really well. It's not very expensive. Once you get into very large data volumes, it can be quite expensive, and people often turn to like Attunity, which is now that Click product, or to HBR at large scales. Documentation's fantastic. I mentioned that. Disadvantages: on-premises data sources, especially older data sources like Progress and whatnot, are harder to use. Non-standard APIs that are not one of their 170, and 170 is the number I'm using. I'm sure they've got more now. They're building them every day. Non-standard APIs are a little bit challenging to connect with. I actually worked through that process with one, and I found it to be time-consuming. I think once you've done it a few times, you get better at it, but it's not that easy to learn. And you can't really do real time, right? To do real time data ingestion, you need a tool like Kafka, and you need events defined. And there's some challenges here which FiveTran doesn't really address. Now, realistically, how many people actually need more than every 5 minutes, like real time? People that think they do, most of the time don't. So maybe real time doesn't matter, but if it does matter to you, like if you're an air traffic controller, 5 minutes is definitely not long enough for you to get data updates. You need faster data than that. Any questions about FiveTran as a product, or the things I've listed here, or comments?
Are you covering like what the licensing structure looks like for this product?
I can speak to it. It's really simple. Basically, for each row that you update, it charges you something, and that charge is usually in like the sub-penny range. The one thing that's interesting about the FiveTran pricing structure is your initial historical load is free, right? So they give you, for each new data source that you create, right? Not just like a trial, but each new data source you create, you get 15 days for free. So your historical load is free. And then after that, they charge you every month, and they charge you for all the rows that have either new or have changed. So like if you had a data source that you just loaded once and it was all historical and nothing ever changed, FiveTran would be free for you forever. If you have a data source where you load 100,000 rows of historical data, and then you load 1,000 rows, you load 1,000 rows and you update 1,000 old rows every month, you'd be charged for 2,000 rows a month. Now, the pricing per row depends on the amount of data associated with that row. Really wide tables cost more than narrow tables. Which data sources you're using has an impact, but that's their basic pricing structure. So it's hard to get a quote from them because they don't know how much it's going to cost until you've loaded something.
Sure. Cool.
Questions or other questions or comments? They do work really well for certain data sources that have historically been really annoying, like Google Sheets is one. If you want to load data from Google Sheets, it's always been a big hassle. With FiveTran, it's just automatic. It's really easy. You can load like a Dropbox folder, jump a bunch of JSONs in a Dropbox folder and load them all, and all of a sudden Dropbox is like a data lake for you now, which is kind of nice. Next product, SnowFlake. SnowFlake is a columnar cloud database. It auto scales for you. It creates indexes by itself, meaning that DBAs are less necessary, although not completely irrelevant. And it also does a nice thing where by auto scaling, I mean, it can automatically replicate. So if you're in the middle of a nightly load and somebody, like let's say the CEO hops on at night, pulls up Power BI and wants to check and see what's going on, right? It can split the database. It can create a replication of the database where it's still loading, right, into one version, and the other version is available for queries. So the fact that it's loading does not slow down your query performance, which is a fantastic innovation. So advantages, it's auto-indexing, it's auto-scaling, it handles simultaneous reads and writes, which I just described. There's some nice features for JSON. Most columnar databases have the ability to handle JSON better than like a typical non-columnar relational database has. There's ways to parse JSON really nicely if you have a column that consists of JSON data, which is really pretty common nowadays. Some of the Kimball best practices, as we discussed a little bit earlier, can become less necessary, such as auto-incrementing keys, and then the need to look up those keys from a fact table into a fact table from dimensions. That whole process, depending on your scenario, can theoretically at least become unnecessary, which that's often the majority of your load time. So that's just eliminated if you don't do that. Disadvantages, the query tools. So those of you who've spent a lot of time with SQL Server Management Studio, there's a lot of nice features of SQL Server Management Studio. The error reporting, like when it feeds back to you errors when you ran a query that was wrong in some way, is really good. What's it called when you start typing and it fills in things for you? I forget the word for that all of a sudden.
IntelliSense.
IntelliSense, yeah. Its IntelliSense is not as good as SQL Server Management Studio. So there's no really, really fantastic query tools for SnowFlake. My understanding is that you basically just write queries in the web interface. Error reporting I mentioned is less complete. Other than that, I don't know of a lot of disadvantages for SnowFlake. I've heard from people who've used it at large scale that it's actually, because it's auto scaling, it ends up being pretty cheap, which is nice. I have heard some people say that there does end up being a top end limit for how much data it can handle, but that limit is in the multiple dozens of terabyte range. And so most of us will never encounter that. Any other advantages or disadvantages or questions about SnowFlake?
I just wanted to point out a tool called dbeaver that's helpful for querying Snowflake data. It's a universal database tool, essentially. We use it quite a bit at Sub-Zero, and it's been very helpful.
I'm gonna write that down.
Funny name, good product.
Other comments or questions about SnowFlake? Does anybody have experience with Redshift or BigQuery or Vertica, the other sort of columnar databases that provide somewhat similar functionality to Snowflake, to know whether Snowflake is meaningfully superior to those others? It's certainly the one that gets the most press, but that's just because the amount of money that they've dumped into marketing. Okay. Next product, DBT, is put out by a consulting firm that has now basically become a software development firm in Philadelphia called Fishtown Analytics. It is a open source code-driven data transformation engine. So their philosophy, which I think really does describe pretty well what they try to do and what they have, I think, in large measure accomplished. So their philosophy is thus: they believe that code, right? So typing code, not graphical user interfaces, is the best abstraction to express complex analytic logic, right? So for literally my entire lifetime on Earth, almost every database development ETL tool has tried to make a simple, magic graphical user interface that anybody could use to build complex ETL logic. And my experience with those tools is largely that there seems to be no way to get away from needing to hide, the most important switch that you need to switch to get your ETL to run properly in some submenu of a submenu somewhere that actually you have to type code in to get it to work. That always happens, that I've always seen that happens. And so DBT has basically decided, enough, we're just going to write code. People can learn to write code. It's easier than the graphical user interfaces. I think that's number one. I think that's the most core piece of their philosophy. And I think it's a fascinating assertion. That has also been my experience, is that code is just easier than graphical user interfaces. So I'll stop there and see if anybody has responses to that. I suspect people probably have emotional reactions to that statement, positive or negative.
I think it's interesting. I've never heard that before. So thanks for sharing. I could see how it could be useful. I've always kind of liked SSIS though, as far as just being able to understand it pretty well, just by looking at the pictures. But there's always things tucked away, as you mentioned, that are sometimes gotchas.
Yeah, I've loved SSIS for the debugging features for that reason, right? Like, it's really easy to look at. You look at it and there's a little green spinning thing that's loading, and then it turns all green, and then it goes to the next one and there's the green spinning thing and it turns red if it didn't work, right? So you can see the data went from here to here to here to here, and green means it went good and red means it messed up, right? That's really nice for debugging. I love that. And their error reporting is fantastic. But actually building out lots and lots of SSIS packages, I don't know. I hate doing that. Other responses to this concept of code-driven ETL as opposed to graphical user interface?
Heard that, I thought, well, that's pretty arrogant and kind of lazy that they didn't want to write a graphical tool, so let's just write everything in code. But then I actually really sat and thought about it and looked how they did things, and yeah, I agree.
So number two is related to this, that data analysts should adapt similar practices and tools to software developers, which means version control, automated testing, merges and branches, all this stuff, which their experience, which seems, this actually is probably the most shocking thing of this entire presentation to me, which I have not yet seen evidence of, but their assertion is that their experience is that data analysts can handle that process. It's not over their heads. Number 3, and these last 2 are open source related. Critical analytics infrastructure should be controlled by its users as open source software. I think the biggest reason for this is that assuming your company that makes your analytics tool goes out of business, which Microsoft won't, but there's certainly been plenty of others who have, that should not mean you can't use their tool anymore. You should be able to see the code and modify it if you need to. And then the analytic code itself, not just the analytics tools, will be increasingly open source. So DBT has this really, really well-established, very large community of people participating in this Slack chat that they have that's become massive and like sprawling, of people who are building plugins to DBT to enable additional kinds of functionality. So it's open source code-driven transformation engine, the T in ETL. Advantages: it can automate testing, version control, and deployments because it is fundamentally code, and so it could be managed through a Git repository and through pipelines. It is easier to create models, right? So one thing that's annoying about DBT is they like to use words for things, right, that are not the normal words that you use. And those words you're used to having other definitions for those words. So they use the words models basically to define like ways that you can transform data. So if you make a view, right, that's a model. If you write a query that you could use as a view, but you set it down as a table, that's still a model. So they reuse this term model, which I think is misleading and confusing. But the fact that you can do your transformation logic in basically a view means that analysts can do it, right? So you can share the load between database developers or engineers and analysts. They can actually participate in the data warehouse development process in a way, probably not completely, but at a higher level than previously would have been possible. There's a great user community, there's macro libraries, that kind of stuff, that's nice. Disadvantages: if you decide at some point that you've reached a scale where you need auto incrementing tables, right? Your database is not fast enough anymore, you need to go back to the Kimball model of using, low granularity integer keys. DBT does not really enable that. There are workarounds, but they're not great. And I have not observed, right? So I have not observed, and I don't know anybody who's built a very large scale implementation with DBT to say how well it works at scale, especially when you're not using auto incrementing keys and you're using views for your dimensions in your fact tables. Comments or questions about DBT? And anybody from Sub-Zero who's used it that wants to share anything else, feel free to do that.
I think it sounds really like a pretty cool product. So thanks for sharing it tonight.
Mm-hmm. Oh, one other downside to DBT, it does not connect to SQL Server. There is a workaround where people can connect it to SQL Server, but they have found poor performance. So it is not a Microsoft Stack product. Compatible product. Okay, I'll keep moving because we'll have to decide whether we want to do a demo. We're definitely going to be over time. So Sigma computing. So Sigma is it's not a popular BI tool. It's brand new, right? So nobody's using it. The reason anybody's paying attention to it at all is because the people that funded SnowFlake also funded this. And so everybody's like, well, whoever was funding SnowFlake was clearly a genius because they picked the diamond in the rough. And so maybe they can do it again. So that's the reason people are paying attention to Sigma. So I've explored it, I played with it, and I do see that it is interesting and it is a bit of a new approach to BI. Interestingly, some of the reasons that after talking to Sigma that they said that was great, I wasn't impressed by, but I actually thought some other reasons that they didn't even identify were pretty interesting. So basically, So I've been in the BI world long enough now, and I've played with Power BI and Tableau enough that I have a pretty good sense as to how the process works. So Sigma basically tries to do as much as possible to get the experience of building out data visualizations and measures like calculations, BI calculations like Excel. They want your experience to be Excel-like, right? And what they end up doing is you build columns, right? So you can build measures, and your last step is usually building measures that you drag onto a visualization, but you do it one column at a time. So like for those of you who've worked a lot in Power BI, know that you can write DAX measures that get to be 100 lines wrong and have 100 lines long, and have multiple variables and do a million things, and you're creating like basically table variables that you combine with other table variables, and you can do some absurdly complex calculations in DAX. And DAX is remarkable because then the tabular model can process those calculations really fast. It's an astoundingly amazing product, and I think there's a good reason it's way off by itself in the top corner of Gartner. But to build those complex DAX calculations, you need to be pretty proficient at DAX, which means you probably need to have read Marco Russo's book at least halfway through. And anybody who's read Marco Russo's book, like I have, knows that it is no easy read. It is complex. So Sigma really tries to make that simple. So you build columns, right? So you build one column, right? And if you want to get to a complex calculation, you'll build 20 columns. So you'll build one column, and maybe that column will be aggregated up to the year level or something. And then you build another column that's aggregated to the day level, and then you'll divide them, right? So you build out these aggregations at different levels, sort of one column at a time. And so you don't build these really, really complex calculations. You build a bunch of simple calculations, and then you combine them together at the end, which is just exactly how Excel works, right? You take one step at a time, and many people can do this. Many people can use Excel well. And then at the end, you run a calculation that combines all the things that you built in the intermediate state. So Sigma doesn't feel like using Excel, right? Because you're not building cells, you're building columns. So it doesn't feel like Excel. It feels a little bit like Power Query. But in the end, you can stack a bunch of simple calculations together to get to a relatively complex calculation, which a person who doesn't have a ton of experience, like you would need to write that DAX, could do that theoretically in Sigma. Now, I haven't seen a rollout of Sigma like side by side with a rollout of Power BI to know whether users really do find it to be a lot easier. But the concept that it does seem to be easier, and it is designed to be easier, I kind of buy. It really does seem like there are aspects to it that that do work like building blocks, like Excel does. It pushes the SQL back to the database, so it doesn't have its own semantic layer, and the SQL that it pushes back to the SnowFlake or whatever database is pretty efficient SQL. So like when DAX in Power BI is translated into SQL, it's not necessarily that efficient of SQL, because that's not really what the language was written to do. It was written to process against a tabular model. It wasn't written to convert back to SQL. So it converts to relatively efficient SQL. Disadvantages is that there is limited ETL functionality. So like Power BI, you can import databases, or you can import data sources and actually store the data in Power BI, do your transformations through Power Query, and then model the data and then write measures. It doesn't include the ability to do all that. It's really meant to push that stuff back to the database. It can do some of that, but it's not as sophisticated as Power BI or Tableau in that area. It doesn't have a great pricing model for small customers, which this is the area in which it doesn't super fit my premise here of 75 or whatever, 10 to $75 million customers. To get started with Sigma, you pay 30 grand for your, platform fee, and then you pay for developer licenses. So you can scale out, right? So user licenses are free, view licenses are free, but developer licenses I think are 500, and then you have your $30,000 platform fee. So getting it to try it, they'll offer you a really long trial. They'll offer you like a 3-month trial because they're a new product. They really want people to use it. But once you buy in, it's a pretty hefty one-time fee for a small company. It's less flexible. You can definitely not build as many different variations of things. The code and the options for writing their code is less sophisticated than Power BI or Tableau. So I think it's meant for users who are not super sophisticated, right? For the sort of self-service model of BI, which a lot of companies have tried. I haven't been aware of any really dramatic success stories, partly because BI tools are just inherently complicated. What they're trying to do is inherently complicated. This one seems like an interesting approach to self-service, but as any tool that's meant to be simple, it can't do as much as those who are meant to be flexible. And so yeah, that's Sigma. So questions or comments about Sigma? Okay, so you can see my information here. So I guess this is time where we get to the question, like, do we want to do a demo? I can probably run through a demo of all 4 of these tools in maybe, I don't know, 20 minutes, but that'll definitely put us well over time. So I could pick one if we wanted to do a demo of one of them, or we could just call the discussion, the end of the presentation and talk if we want to do any of that.
I would stay for the full demo.
Same here.
I'd be interested in the demo.
So would I, especially FiveTran.
All right, well, let me pause for about 2 minutes because I have to go to the little boy's room. I'll be right back. This is the conference you were just talking about, Bridget. Any questions or comments or anything you want to make sure I cover in the demo? What we're looking at right now is something that I made for my daughter. She's 6. So when she gets money, she can put it in a jar in the living room, and I input it into this spreadsheet. And then each month that she keeps the money in what I call the bank of dad, she gets 10% interest. So 10% interest each month, not annually occurring interest. And so I'm basically trying to teach my 6-year-old daughter about compound interest to help her understand how to think about money. So this is a Google Sheet. There's nothing especially special about this. I just want to show you that I have a data source that you can import. So we go to FiveTran here, and I'm going to add a connector. And I'm going to do a Google Sheet. And I need to sign in, which I'm already signed in to Google. So if you have your email normally signed in, that should be pretty much automatic. So I'll sign in using my Gmail address. And let's see. Oh, why does it think that I'm not logged in? Oh, because I signed in with my Google. I see. That wasn't actually creating a connector. It just passed me back to the FiveTran sign in, which I did wrong. Okay, now I'm going to add a connector. I'm going to add a Google Sheets connector. And this is the screen that I was expecting. So the destination table. So now I'm defining, so this is defining the schema it's going to put the data in, right? And the destination table that I'm going to call it, I'm just going to call it bank of dad, and I'll call it 3 or something, because I think I've done this a couple times. The sheet URL. So I'm just going to go to Google Sheets. I'm going to grab this. Actually, I think I have to share it. I click share, and I'm going to get a link. Copied the link, paste that here. It's going to find it. This is going to take maybe, oh, that was quick. I'm going to click, and you have to define a named range. So I defined a range. I saved that. So it's just making sure the sheet is there, validating the named range exists, and then I'll click load and it'll load it. And once it's done with that, from this point forward, any changes I make to that Google Sheet, any new rows I add, any rows I delete will be automatically handled with change data capture based on the row number of the sheet. So that's my primary key for my source system. Not sure why this is taking a little bit longer. It took a little bit quicker last time I did it, but it won't take super long. Okay, connections passed. So it knows it's there, it found the data. Now I'm gonna do my historical load. Start initial sync. It's going to start syncing the data, and you saw there's like 20 rows. So the main bit of this is just connecting it, creating the table in Snowflake. So what it's going to do, it's actually going to create that table in that schema that I defined in Snowflake and push it there. I didn't show you how I connected my destination to that. It's really easy. The explanation is very simple. You do have to go through in Snowflake and define some security parameters and give FiveTran access to it, which is pretty easy to do. Sorry, I'm gonna have to log into all my database stuff just because I didn't look at this since yesterday. Check on FiveTran, it's still going. So yeah, you have to define this FiveTran database, and you have to go into security here and define, like you have to give permission for FiveTran's IP address to connect to things and define some users. There are ways to do this with a key vault, but I didn't because this is just a demo. So we'll give this maybe one more minute to sync and to create the table. The table in Snowflake might already be there. Let me see if it's been made yet. So Bank of Dad 3, is that here yet? Nope, it's not there yet. Feel free to jump in with any comments or questions as we're waiting for this to sync. It's interesting, this is taking longer than it's taken for me in the past. I wonder if 7 o'clock on Thursday night is a time when a lot of people are hitting FiveTran load compute clusters or whatever. Or maybe hitting Google Sheets, I don't know. Anyway, while we're waiting for this to go, I do have a previous version that I've created in here. Here's an older one. So I'll just, show you that I can select data from it, and the data is essentially what was in that spreadsheet that we saw before. Oh yeah, so there's Bank of Dad 3. So one nice little feature that Snowflake has is you can select an area and then do, place name in SQL, and then it places the name of the database there with its full path. And so you see now the data and the schema has been created in Snowflake. I didn't have to go into Snowflake to do anything, right? I could have run this process and never have actually opened Snowflake, the database, except for back when I created the security processes, which you can make your DBA do for you anyway. So yeah, data's in Snowflake. Any questions or comments about that process of FiveTran getting the data into Snowflake?
If you wanted to pull it or refresh it daily, would that be pretty easy to set up too?
Yep. So sync frequency, I just have this slider right here. That's all it is. It's automatically set up for 6 hours.
Great.
The tier that I've paid for, 15 minutes, is the best you can do. If you pay a higher tier, you can go down to 5 minutes. I'm sorry, I interrupted somebody.
And you just pay for volume, so if there's no changes, there's no charge?
Yep. Okay, so the data's in Snowflake. I have a couple other data sources that I imported from Dropbox and other places that we'll see, and we look at Sigma. So I have a date table, just a date dimension that I created. It's the standard Kimball date dimension. And then I created a table that includes transaction type. That's just a really simple, like, for my daughter, when she spent money, that's one transaction type. When she deposited money, that's another transaction type. So I'll show you what that looks like. This is really simple, hard-coded, right? And then here's like, some metadata that FiveTran automatically pulls in. The line, this is the key, and the modified date. And so I can see transaction source, Walgreens, Build-A-Bear, and whether it's an investment or an expense. And so it's just categorization. So we go into DBT, and I'm going to do a new project.
I've got one question.
Yeah.
What browser are you using?
Edge.
Okay. I really
Yeah,
like
these
the way the
vertical tabs are nice.
Yeah.
Let's see. Oh, wow, I forgot how to create a new project. And I just did this yesterday. I could click around unless somebody who uses DBT on a regular basis remembers how to create a new project. Just tell me where to do that. Let's see.
I don't create a project often, but it might be in your environment or account settings.
There's a new environment tab, jobs. I can create a new job. Maybe in my develop area.
Should be in there. It might be.
Well, worst case scenario is I'll just show you what's already in here. Yeah, I'll just do that. It's not that, creating a new project isn't really that exciting. So here you can see my models directory. And, as I discussed earlier, a model could be a view. A model could be an instantiated view, right? Where you take the view and you actually set it down on disk, which you can do in SQL Server 2. A model could be a table, or a model could be a table that's set up for incremental loads. They're all called models, which I don't like, but that's what it is. And you can't change it. So tough luck. The first thing that you do typically is you create a YAML file. What a YAML file is it's like metadata. It's purely metadata. I first experienced YAML files in Azure DevOps pipelines. You can define YAML files that give the information about where you're going to pull your release, or your build and your release from, and where you're going to deploy it to. So like when you want to do automated deployments from like your dev to your test environment, or your test through an approval pull request process into your production environment, usually define those deployments using YAML, but it's just essentially a metadata file. And so here you go in and you define the name of each of your tables, right? So the name is, so I think this is the schema name. And then here's the tables in that schema. I only have one. This one's called Google Sheets. I think actually I called it in this case, what did I call it? Bank of Dad. And then I have my table I have my schema Dropbox, and I have a date and a transaction type table. Let me just verify that it's called Bank of Dad 3. I think I had an underscore in there. Yeah, I better put an underscore in there. And then my models, right, which is my destinations, my views, or my tables. So I create a name for each one. I give a description, right, which this is, then useful because this is picked up by any data catalog products that you use. So DBT is really well set up to capture metadata so that then you can feed it back to a data catalog, which I've never been real impressed by data catalog solutions, partly because the metadata just isn't there. But if you're using DBT and defining the metadata like this, then it would be. So your data catalog could work quite well. And then you define column descriptions if you want to, and you can do tests on individual columns. So you can test for uniqueness, you can test for whether there's nulls, you can define your own tests. This is where you would do automated testing. So this is my YAML file. YML is the extension. And then when you're actually writing your query, you use this kind of code called Jinja. I don't know why they called it Jinja. Some kind of pun or something, I'm not really sure. I didn't bother to look. Where you basically define this different kind of SQL macro. So this translates into SQL code, where it actually pulls the Google Sheets sheet. But when you define it as a source like this, it pulls the metadata along with it, and it allows you to do some neat things, including something I'll show you in just a little bit. So I can preview my data. So here it's referencing the data from the YAML file. And this is pretty slow. I find this kind of annoying when you want to test your DBT models running the query. SnowFlake is really fast. Why it can't be fast here, given that it's just pushing the data back to SnowFlake, I don't know. But for some reason, it takes a while to run queries. I mean, you'll see what the SQL looks like when it's done after it's been compiled, you know, and they've run the Jinja through the, you know, compiler and generated the SQL. So basically this markup language converts to SQL data sources. There's lots of other things you can do with this Jinja markup language, including defining if and for statements and loops and stuff. This is taking even longer than I would have thought. I wonder if my connection's broken or something. Yeah, go ahead.
I have a question that might fill a little time. Now, this is the one that had the $30,000 platform fee, the DBT? Nope. No, which one was that?
That's Sigma.
Oh, so Sigma. I see. Okay.
I don't have a lot of experience with DBT pricing. Do you want to say anything about DBT pricing, Michael or Jason?
Sure, I can talk a little bit about it. So it's open source. So if you're just using the command line client, it's completely free. Just you agree to the open source agreement. They do have enterprise agreements as well, so they do have a cloud option. We personally decided to go with the cloud option at Sub-Zero, primarily so we can get support on the platform and get some assistance in setting it up. But it's then you pay by developer. It's reasonably cheap. I think it's like $1,000 a developer per year, or something like that. So I don't know the exact pricing, just pay a number, but it's relatively inexpensive.
I think something's wrong here. I'm going to try to refresh this and see if I can't get it to reset on me. I don't know why it would take that long. That is not my typical experience with that happening. I won't go into all the ways that this interacts with Git, except just to say that there's this commit button up here, and you know, you can create a new branch or whatever if you want to. Compilation error. Oh yeah, so it's trying to call this here. If you remember in my YAML file, I renamed that to this. So maybe that's the problem. It was just trying to call something that wasn't there. So I'll try this and try to preview data again. If this takes more than 10 seconds, I'll probably quit again. Just go back to the way it was. You know if there's a way to stop the query, Jason?
I don't think there is.
It appears that I can save while it's running, which that's nice. So I don't like lose my work.
Might be able to close the tab then. So it looks like it's actually running something, but.
Oh, so it's processing
anyway.
Something in the background. Let's see. So DBT, can I DBT compile? Looks like I can. So it's going to give me my actual SQL code that results from this Jinja stuff. And I think I can't see my compiled SQL here. Why is that? Details.
I believe that compiled SQL actually gets put into a target folder within your project.
Oh, okay. I'm trying to remember what enables me to see this. Is it just when it finishes querying?
Yeah. So
okay.
on the left there, you have that target folder. You can actually see all the compiled code in there.
Oh, okay. Yeah, so this is what it looks like when it's translated to SQL, you know, which is basically what you expect to see. And this was pretty simple. The main reason you would do these data, you know, these Jinja codes is something I'll show you actually right now. It's basically for metadata management. It will give you your lineage graph, so you can see what your data sources are. This is like just sample data up here, but this is mine. I'm pulling date, transaction type, and my data from Google Sheets, and I'm pushing it over here. So it shows your lineage automatically based on your queries if you use the Jinja code, which I think is actually really nice. When you get to a large enterprise data warehouse, your lineage can become pretty nightmarish when you have hundreds of tables. And so, I've seen models that have hundreds of tables and you can still tell what's going on. And so that lineage is really nice just right out of the box. And you can see also your, the data that's going to be fed into like a data dictionary is stored in here as well. So then I would do dbt run, and this actually publishes this view back to SnowFlake. And it runs my automated tests, right? So you remember I tested for uniqueness and I tested for nulls. I could test for lots of other things. And if I failed any of those tests, it would error out. It would not publish it back. So this was called bankofdad.sql. So I can look back here and I can see my, let's see, what schema is that in? Okay, put it in here. Yeah, here's my bankofdad.sql. And my code is just like what we saw in the DBT here. So, so it's kind of interesting. You just write a select statement essentially, and there's certain macros you can use if you want to, these Jinja statements to, which basically work like SQL functions, but SQL functions in SQL Server are slow. Depending on what kind of function you write, these Jinja statements just translate into SQL code, which is run directly against the database, so they're not slow in the same way. And so, yeah, you can see all I did was write a SQL query and it created a view in here. I didn't need to write create view as. If I was creating that as a table, I would just in my YAML file define the instantiation as a table as opposed to a view. And then like if I wanted to have an analyst do it, I could just have them write the SQL query and then they've created the object, which can be kind of nice. And then you can check that into source code too. Any questions about DBT? This is a really complex product, can do a ton of things. We haven't looked at very many of those things.
I just wanted to point out as well, if you want to run the test, it's actually a different command. It's called, you have to run dbt test to run those tests.
Interesting. So the run command doesn't run the tests as well?
Correct, it does not.
Oh, okay.
Just deploys those models.
You can tell that I am not the most experienced person on this call with DBT.
So I think
I actually got a failure. And this was in a sample.
Their original example has a failure to show you what happens.
Cool. All right, any other comments or questions about DBT? Okay. All right, so now let's look at Sigma. And I'm just going to refresh this to make sure I'm actually logged in. And the same problem I had with the other ones. Okay, it looks like I am logged in. Okay, so I'm going to, let's see, my documents. I'm going to create a worksheet. And I'll create a worksheet based on table in one of my database connections. So I've already created this connection to Snowflake. And I'm going to select my Azure Snowflake connection. And I'm connecting out of my FiveTran database in my Google Sheets Bank of Dad 3 connector. Okay, so you can see now I have a spreadsheet view. And let's say I want to do some kind of calculation. Right, so I want to take, maybe I want to look at the year, right? So first I'm going to do a new column. Let's see, this is not the view that I'm used to. Where's my view that I'm supposed to have on the right? Let me go back here real quick. This is the view that I'm used to. I don't know how I lost this. Sorry, I'm not super experienced with these tools. I just played around with them a little bit. So I'll just work with this. So here's an example. I basically had just imported this data source, and this is the data that you saw before with investment and expense and all the things that my daughter, has in there. I think I deleted some columns. I just hid them essentially. And I've created this investment date column, which the date over, where was I hid the date. How did I do that? Sorry, this isn't the best demo in the world. Essentially, I created it, so there's the other columns that were originally there are hidden. I created an investment date column, which just pulled out the date as a date format. And then I aggregated up that date to the year. So you can create an aggregation column, which aggregates up and summarizes other columns as a new column at the aggregated level. Now, for those of you who've worked in the BI world for a long time, there's lots of use cases where if you aggregate something as a column, then that can make for some nice shortcuts to be able to do things with that aggregated data, such as divide by other things and build out measures. And here I've done something where I've just at this aggregated year level, I've just summed all the investments. So all of my daughter's investments by year, I've summed up here as a column, and you can see them. And then here I've done the maximum. So the maximum investment summarized as a column. And so all I had to do to create that column was choose the year of investment date, and it aggregated it for me. And then here at that level of aggregation under the year, I created investments and then largest investment. And you can see, here's the investments by year that I put on this visualization. So I just dragged over investments by year. I could also drag over largest investment, and it'll graph my largest investment by year on this simple visualization here. So this is a pretty similar view to Tableau. And then when you want to make data visualizations, let's see, where's my data visualization example? I think you make a dashboard, and then this dashboard has different tiles, and you just pull those visualizations on to each of those tiles. Let's see, why is this one showing all blanks for me? Let's see. So this is the dashboard symbol. I swear this one had stuff in it. I want to know why it's showing empty stuff now. Weird. All right, well, I do have this other dashboard that I had made, or maybe I just could make a new one. Here, I'll be brave and I'll make a new one. So I'm just going to create a dashboard, and I'm going to add a visualization. So I'll go to my Dank of Dad worksheet we had, and we had investments by year. And you can see that original thing that I had here. And I can add another one. And I can lay it out in different ways. There's like in Power BI, you can size things and lay things out as many different ways as you want. This is an attempt to simplify things. You don't have an unlimited number of ways to lay out a dashboard. You just have a few ways. There's like, a couple of hundred ways you can lay out a dashboard. And so you can build it like this. And then you can publish this out, and you can embed it really easily into another website. It's pretty flexible in terms of where you want to publish it to. But my personal opinion is that the core innovation here is this, this ability to build out new columns and to build them out as aggregations, so that when you want to create complex calculations, you do it one step at a time. And then I believe that there's a way to build measures up here, which I actually never did. I think they're called parameters. And then you can use those like Power BI measures that depend on these different columns. So any questions or comments? I might not be able to answer your questions. This is the tool of the ones that I'm probably least familiar with. I'm interested in people's reactions to Sigma. I know this wasn't the best demo and I made a lot of mistakes and I didn't cover all the features, but this concept of building out columns at different levels of aggregation and then combining them so you can have little building blocks as opposed to building out long DAX measures. You know, how do people feel about that? For those of you who've done a lot of BI, does this seem like an important innovation or does it seem like it's oversold? I don't know how to feel about it, honestly.
Yeah, I'd have to try it out a bit to kind of see what I think about it. Do you have a license or is it free to try this out or?
Yep, you can do, I think it's a 30-day trial. And because they knew I was doing this demo and I'll be doing another one, which I'll prepare a little better for later this month, they just extended my license for like 3 months.
Yeah, it's definitely cool though. Something to definitely watch. How long has this product been out for?
I think it has existed for maybe about 1.5 years, but they're on this like, you know, venture capital funded like very rapid release cycle. So it's come a long way in the last year, and they're making massive changes to it like every week.
Is there any geographic features at all? Mapping features?
Yep, it has some mapping features. I have not tried them. That's a good question because I know mapping is a very glitchy area. Some of the Power BI maps don't work well at all. Tableau maps have generally been the gold standard. I don't know how well these work.
Cool.
Are there other tools in the space? You mentioned that Power BI doesn't play well with SnowFlake. I forget if you mentioned other visualization tools.
So I think if I said that Power BI doesn't play well with SnowFlake, that was a little bit of an overstatement. Power BI really likes to have the data in Power BI. So you can get all the advantages of SnowFlake except for using it as a semantic layer. So you'd want to suck the data into a tabular model or into a Power BI data set from SnowFlake, and then use that as your semantic layer. So Power BI can work on top of SnowFlake very well that way. As a direct query engine into SnowFlake, it's not as good. I've known of people using Tableau for that and having some success. I've also known of people using Looker for that. That's probably the most common use of Looker actually, is direct querying into Snowflake or to Google BigQuery. Those are the two other ones that I hear a lot about. Sigma is really brand new on the space, so there's just not that much out there about it. This was bleeding edge experimentation for me. Okay, well, we're certainly over enough time. Thank you, everyone, for sticking around. I hope this demo was worth the extra time. Brigitte, anything you want to say to wrap us up?
One sec, Jeremiah, can you recommend any books, like textbooks or that cover this kind of thing?
We've covered a lot of things really lightly in this presentation. When you say this kind of thing, can you be a little more specific?
Well, I guess yeah, there was a lot of things. I guess from the data analytic point of view of from these tools.
I don't think there's any books that really do this larger topic or even like one slot of this topic great justice. There's a fantastic tool on using the Power BI query language. There's some great books on Tableau. There's some great books on Snowflake, just showing you how to use them. But looking at the larger data stack from like a perspective of where everything's been, where everything's going, everything is changing so fast that a book would be out of date in a week. And so I haven't seen any good books trying to cover any of this from like a swath perspective. There is a book that's actually a little bit out of date from a history perspective that's kind of interesting, called Data-Driven Applications, that looks at application like, you know, software development websites and how you use underlying data to feed into them, and where like some of these big data tools fit or really honestly for the most part don't. That's an interesting book, but I don't know. This analytics space is kind of so fast moving. It's hard to really find books that address it well. If you want to understand the Kimball data warehousing methodology, which I think a lot of everything has always been built on, and even in this new world of sort of modern data stack, understanding Kimball is still, I think, really essential. Kimball has his own books out there that are great.
Sounds good. You'll have to write one.
Leave my legacy for 5 minutes till it's out of date.
If you're
The
looking
online
to learn,
communities are great. Sorry, Jason.
no, I was going to say, if you're looking to learn DBT stuff, I just put a couple links out there that I've found helpful. Their documentation is actually pretty good, and then they have a free on-demand training that's decent as well. So.
Fantastic. This is pretty good. This is a really good overview of a lot of technologies today. So thanks for going a little over, and thanks for everyone for sticking around.